Hi guys, this is a calculus video, 5-4, so the fourth video of Unit 5, and this is to be watched the weekend of Friday, January 10th. The homework that corresponds to it is on page 8, and it's number 2. And I believe that the homework problem is very similar to this first example that we're going to do. So find the area under the graph of f of x equals 2x plus 1 from x equals 3 to x equals 6. And guys, the area under a graph is the area between the graph and the x-axis over a given interval. Okay, so the first thing that you should do in a situation like this is graph the function. This is a line, its slope is 2, and its y-intercept is 1. So it's going to look something like that, okay? And we want the area between this line and the x-axis on the interval 3 to 6. So let's say that right here is 3, let's say that right there is 6. So we're looking for this shaded area here. And it's never a bad idea to find the coordinates that are the vertices of the shaded area. Okay, so like right here, this is a quadrilateral, it's a trapezoid. So we're going to be using the area of a trapezoid to find this shaded area. But we've got these vertices, so that'd be 3, 0, that'd be 6, 0. Now let's find these ones. All right, that's going to be 3 something, that's going to be 6 something. And now ask yourself, how do you find the corresponding y-coordinates of those? You would plug the x-coordinate into the function. So right here, this is the graph of that f of x. So if I want the corresponding y-coordinate, I would just plug 3 into that function. And I've already done this, and I got 7. And when you plug 6 into that function, you get 13. So there's the corresponding y-coordinates. Now here's an observation. This shaded area is a trapezoid. So the area is going to be 1/2 base 1 plus base 2 times the height. Okay, so in this case it's going to be 1/2. This is a trapezoid that's like on its side. Okay, the bases of a trapezoid are the parallel sides. So really, that's the usual way we're used to looking at trapezoids. So that would be base 1, base 2, or vice versa. It doesn't really matter. And the lengths of these bases are the y-coordinates. Because the y value there is 0 all the way up to the y value is 7. So the length is 7. The length of that base is 13. So 7 plus 13 times the height of the trapezoid, it's going to be the perpendicular distance from one base to the other. So here it's just the distance between our x-coordinates, which is 3. Okay, and when you do that math, you end up with 30. Okay, so I'm going to say this. I'm going to say therefore, and I'm going to use calculus language to write my final answer. So I'll say therefore, guys, this is not an estimation. This is the exact area between the function and the x-axis on that interval. It's the exact area. So I can say it like this. I can say therefore, the integral from 3 to 6 of 2x plus 1, okay, dx at the end, is equal to 30. Because the integral from 3 to 6 is the same as the exact area under the curve on that interval. Okay, that's the meaning of it. Okay, so there's one example. We only have one more example. Okay, so in this one, you're going to find the integral from -3 to 4 of f of x, and the f of x is this piecewise function. All right, and guys, what does an integral mean? It means exact area. So exact area between x-axis and f of x. Okay, so that's the meaning of that. I would write that down for your notes. And then I'd write something else down for your notes. So let's say this. Let's say note. All right, I wrote this yesterday, so I'm looking at my notes. With integrals. Okay, so write this down for yourself. With integrals, if the graph is below the x-axis, the area is negative. Okay, before calculus, any areas you've worked with have always been positive. But in calculus, you can have negative area, and an area is negative when the graph is below the x-axis. Okay? Alrighty, so let's take a look at this graph. So the integral is the exact area of the region formed, or it's the exact area of the region that is between the graph and the x-axis. So so here I've got like a semicircle. So the region formed by the semicircle and the x-axis would be this shaded area here. Okay? And then the graph goes below the x-axis. So here's F, here's the x-axis, so the region formed by between the graph and the x-axis there is that shaded triangle. And then the region we're looking at goes from -3 to 4, so that's 4, so I'll go like this. And then the last bit that we're working with is that area there. So an observation to make is that to find the exact area between F and the x-axis, so to find this integral here, we could split it up into 3 separate shapes. All right, so let me call this shape's area A. Okay, so I'll call that area A. I'll call this area B, and we'll call this area C. So if we wanted the area of the total shaded region, we would just have to do A plus B plus C. But note, B is going to be negative. Okay, so the area here is going to be, should be a negative number. Or we'll find B like it's positive, but then we'll subtract it later. That's how we'll do it. Okay, so off to the side, I'm going to say that A equals, this is a semicircle, it's a half circle, so it would be pi r squared for a full circle, but it's a half circle, so we'll divide it by 2. And this is pi blank squared over 2. For the blank, I need the radius of this circle, and you can see that it's 2 units. Okay, so we end up with 2 pi. Okay, that's the area of the semicircle. Then for B, guys, I know I said that B would be a negative area, but I'm going to find its positive value, and then I'll just subtract it when I'm putting the pieces together. So it's going to be 1/2 base times height. So this is going to be 1/2. The base of that triangle is 2 units. The height is 1 unit. So we get just 1 square unit for the area of B. And then for C, it is 1/2. The base of that triangle is 1. The height of it is 1. So we get 1/2 for that one. Alrighty. And so, guys, for these areas, all right, so let me make this observation here. So we're going to do A plus B plus C, or A minus B plus C. Okay, so, but I want to use the calculus notation for this, okay? So this integral, guys, here's a nice observation. This integral, I could split up into 3 separate intervals. Okay, so I could do the integral of this part, integral of that part, and then finally the integral of that part. So let me do that. So I'm going to go like this. The integral from -3 to 1, okay, that would be this first section of f of x dx, plus the integral from 1 to 3, that's that triangle there, f of x dx, plus the last piece is the integral from 3 to 4, f of x dx, okay? And then I already figured out that this was, so this will be A, and I figured out that that was 2 pi, plus that one is B. I figured its positive value was 1, but it's below the x-axis, so that's going to be a -1. And then plus, for that part here, okay, this definite integral is a half. And when you put it all together, you get 2 pi minus a half. Okay? So that is the exact area. So with geometry, you can often find the exact area. We don't have to use like a Riemann sum to approximate, because we don't even have to use limits. We can just use our notions of geometry. Okay, guys, so there's that. I am not going to add any partner problems for tomorrow. So what we will do tomorrow is I will give a little quiz that is very similar to your homework problem. Let me make sure the homework problem was like example 1. So page 8, number 2. Page 8. Yes. Okay. So we'll go over this homework. Then I will give a quiz that is very similar to the homework. And then I'll just let you catch up on partner problems or move ahead on videos, because I'm going to make at least one more video today that you can watch. Okay, guys, yeah, because I know I was out a lot last week, and that might have set some of you behind if you couldn't ask me for help. Alrighty, guys, so I will see you tomorrow. Bye-bye.